Yeah, good afternoon. So you are able to see the slides, right?
Yes, sir.
Okay, fine. So we will just go through a quick process of whatever we have studied. We started with module 3 with data formats, and where we have seen structured and unstructured data. So you also have seen that different process of data transmission, like industry, transport, building, traffic, then human, and all this contributes to data. And further, we take this data to the internet, and you have the process of database as well as cloud, where you store the data as well as you transfer the data from one end to another. And you have also seen structured data, where you have seen that text data have a predefined structure, and you also have understood that preliminary created the data like phone numbers, social security numbers, and other such informations fall into this category. So these things is what we have seen. So along with that, we have also understood that the data is associated with flight reservation and train reservation, where we have a structured format of data process like banking system and all. So the language such as structured query language, you can call it as SQL, and it is used basically in the data in RDBMS. And we have also seen the next is unstructured data, where there is no specific structure, and you have also seen that have no predefined structure. And usually this we use for an example of human generated unstructured data, like text, sending text messages, sending emails, and all those things fall under this category. So these things is what we discussed in the last class. Along with that, we have also understood some of the examples like surveillance of videos and satellite imaging, and all those things fall under this category, where you know that there is an unstructured data format, and data type does not have a fixed format here. And this like queuing algorithms to perform a lookup table process. So these are the things which we have discussed in the structured and unstructured data. Then we also have the importance of processing in IoT. There we have seen that different processes are involved in processing in the IoT, and sometimes the importance of data is very high, where you have to process it faster, and some of the cases the processing can be taken a bit of time. So we have classified into very time critical and time critical as well as normal. So these three classifications we have seen. And most of the data like flight control system, healthcare, all these are very important informations which has to reach from the source to the destination at the fastest pace. So we go for very critical transmission of data, and we have to make sure that the processing takes place faster, and the communication takes place between the nodes faster. So this is what we discussed in that classroom. And we also have seen that very low threshold processing latency. We also know that what is latency, delay in the network communication, where the process of communication from the source to destination, which takes in milliseconds or in some seconds. So what you have to do is, when we are going for a very much fast transfer of information, so in some of the application it demands like very critical very time critical information flow, and we can say that these informations has to reach to the destination at the earliest. So these cases, we look into these aspects, and we take care of all the information, whatever it comes to the comes from the source to destination. So also we have time critical as well as normal. It's not that all the informations what you transfer at the from the base to the destination, it has to be that important. Sometimes we have some few informations which, if it is latency is slightly high also, there is no much difference it is going to create. So few minutes also, few hours doesn't matter. Like when you are transferring some mail communication, or you are transferring some videos or pictures and all, so it can be few seconds, or tolerance can be there. It's not going to impact so much in the process. So the need for processing the data in the is very important. And time critical data that require processing requirement allows the transmission of data from remote locations and all. So these are some of the things we discussed in importance of processing in IoT. Then the next topic what we discussed is processing topologies, where in processing topologies we basically focused on two main things. One is called as on-site, another is called as off-site. So you also know that as the network is very massive, and you know that more the information keeps coming, because the time it takes for the transmission, and so those information transfer is very much critical. And you also understand that it is very important for us to have sufficient network facility, or the overall architecture of the system has to be precise in order to have a good transmission flow of information. So we have two large topologies available here. One we call it as on-site, another is off-site. So off-site processing topology is also again classified into two: remote processing as well as collaborative processing. So first, let us go with the on-site processing, which we have discussed in the class. At the source itself, and this is critical in applications of very low tolerance for latencies, and like applications like healthcare and flight control systems, where you basically have to have a good processing infrastructure facility for that, so that the rapid changes in the that will not get missed out, or it will not get lost. Because you know that the applications like healthcare and flight control and all is very much precise applications, where each bit of information plays a major role. If a slight miss happens in the information flow, it can lead to a lot of failures, and it can lead to drastic problems. So we have to make sure that all the events, like whatever it happens with respect to healthcare and flight control as an application, you have to process it at the earliest, and you have to transfer the information to the destination. So the event is dedicated, utilized for temperature sensors, and it's also used with the help of the sensors, whatever you are using. You have to take the information, process it at that remote infrastructure itself, and the node has an option to forward the data to the remote infrastructure facilities, whatever it is available. And once the information is being sensed, what it has to do is it has to process it and then forward it to the on-site processing process. So you can see the figure where the temperature sensor is associated with the node, and the sensor node processes the entire information, and then it transfers to the further processing unit. We have an offsite processing, which is very much cheaper compared to the on-site processing, because of the this allows the latency, and you know that the communication means it is not that precise that it has to immediately happen. You can have some tolerance in the latency as well. So a difference in cost is mainly it happens due to the demand and the requirement of processing itself. And you can say that in the offsite processing topology, the sensor nodes is responsible for the collection and framing of data, and then it will be transferred this in this the data will be further transferred to the cloud, or you can say that to the sensors, means to the platform where it can process it further. So what indirectly it happens is it goes for a collaborative mode of processing, where you can reduce the cost of the entire process. So that is one of the advantage we can say. Then you have the subtopics as remote processing and collaborative processing. So remote processing basically emphasize on the various sensor nodes, and the process of forwarding to the remote server or cloud-based infrastructure, and the processing of data from around hundreds and thousands of sensor nodes can be simultaneously offloaded. So this is what we have already understood at the time of discussion, and ensures the massive scalability of solution and sufficiently affecting the cost of the deployment of the node. We can also look into the remote processing, that the network bandwidth plays a major role in the transmission of information, and the network bandwidth really relies on the precision of the network connectivity, and the sensor nodes and the remote processing infrastructure. So you can see that when you have a remote processing process, you indirectly reduce the cost, and you also make sure that the complexity of the entire process is also comparatively less. And this in this remote processing, we know that the whatever data is being sensed, it is going to be forwarded to a remote server or a cloud-based infrastructure for further processing and analysis of the entire information. So this is one of the process. And the next one is collaborative processing, where you have seen that the scenario is with limited or non-network connectivity. Especially this networks is quite economical for large scale deployment of the nodes, and where each node has the access to another node. You can say that the collaborative network or mesh is being introduced here, which also has the reduces the latency due to the transfer of data over the network, and it conserves bandwidth of the network, especially once the connection to the internet is done. This topology is quite beneficial for applications such as agriculture and many applications of frequency and data processing. And this topology is preferred for mesh networks for easy implementation of this entire network. So you can see in the figure that each sensor node is interconnected in a collaborative manner, and it forms a entire connectivity between each node, has one to another collaboration, and they make sure that the entire process works on fine for them. This is one of the topic where IoT device design and selection considerations we have seen. So design is one of the major concern for any of the implementation process, and it is very much important that you select the appropriate components for the requirement, whatever applications you have. So based on the requirement of the user, so we have to make sure that all the parameters, whichever it is required for the design and development of the entire node, has to be considered. So we have here some of the important considerations which we have already understood and discussed in the last class. Like size is one of the constraint, where you have to make sure that the energy consumption of the node is intact, and there is large the form factor, the energy consumption of the hardware also will be larger, and it should be made sure that it's not so bulky and for the IoT applications to run. So you have to make sure that the size of the device has to be optimum, and can which should be capable enough to handle the requirements whatever it is available for us. Then we have energy and cost. The energy requirement of the processor is most important factor, and higher the energy requirements, higher the energy source replacement frequency, and automatically lowers the low term susceptibility of the entire hardware. and we need to know that how much the node can withstand for a specific means what is its energy requirement and what can be taken care. So similar to that, we have the cost as one of the parameter, where the processing cost of a processor and the cost of the sensor, all these things matters when you deploy the node in the network scenario. And you have to make sure that the cheaper the cost of the node, the more the implementation can be done, and which can have a better performance as well. So cheaper gas and fire detection solutions enables the and includes the uh, for more sensing hardware for lesser cost. So these are some of the things which we can see. So we can also see some of the other parameters like memory and processing power. So you know that memory requirement for IoT devices has to be optimized. There will be volatile and non-volatile memory requirements. Then features such as low data processing, data storage, data filtering, and data formatting. All these processes need certain memory capacity, and this all we have to make sure that the devices with higher memory and what is the cost initiated for that, all those things has to be taken care. We also have to know that processing power. So processing power is vital in deciding what type of sensors can be accommodated with IoT devices, what processing features has to be considered, how much processing power is required for running an application, whatever is designed for. So how the applications can handle videos and images, how much processing capacity is required, uh, what is the application's requirement, and what is the environment is being set for all this process. So this is very important, and so memory and processing power plays a major role in any of the design process. As we also know that IO rating and add-ons are also some of the parameters which we have to consider. We have to make sure that all the components which are being added to that, or which has an additional features you are interfacing with with the device, also have to be checked and discussed. So we also have add-ons like the analog to digital conversion units, inbuilt clock circuits, connection to USB and Ethernet, built-in wireless access capability. So these are some of the features which you can look as the add-ons to the devices whichever you are integrating with. So interfacing and integration of the system at the circuit level is very important, and sometimes some of the application plays a major role in doing all this process. So these things were discussed in the class. We also have started with processing offloading, where we have seen that the IoT deployment and what are the main features, that what are the different as process where we have seen environment and means one of some of the applications like surveillance and all, where we have on-site process with sensing and local processing. We have different sensors for interfacing, and we have the sensor node. Then it is being put into a cluster, local cluster network, where each node communicates with each other. Then we also have the fog processing and cloud processing, where the server, internet, database, and all these devices are where which helps in the data transmission from the source to the destination. So various data generations and storage sources is connected to the internet, and data types connected within it. So this helps us to have a flow of information. That is what the communication can be, a wired communication or wireless communication. You can also go with short range wireless as well as long range of wireless communication between the source to the final destination. So these things were being addressed here. Then For a majority of the IoT applications, the processing is carried out remotely in the order to keep the on-site device simple. And we have also seen that fog-based processing is considered for node and typically localized within the geographical area and servers to the nodes. So we will further we have to discuss upon the data offloading that is divided into three parts. One is offload location and offload decision making as well as offload considerations. So these three parameters we have to discuss in further. So we'll be discussing these things in detail. So offload location means the processing can be offloaded in the IoT architecture based on the whatever what is the need and requirements is very important for you to analyze. Then you have a decision making process where you look into the aspects of offload processing of data and how much time means how much importance of each decision whatever it is being taken whether it is required for you. So some of the parameters we'll be discussing there as well. And then offload considerations, what are the parameters you have to consider at the time of offloading. These are some of the three offloading data offloading is divided into three parts like offload location, then offload decision making and offload consideration. So this offload location is edge and fog. We'll be discussing these things in detail for the upcoming class. But before to that, I just would like to take you through some of the details of that. So we will just go to some of the videos and we'll have a look over that. You can just let me know that if it is visible for you once. Okay. Is that clear for you, all the things, whatever we have discussed?
Yes, sir.
Yeah, further we will be continuing that portions in the classroom. So we'll just go with some of the videos here. So it will be fine to give you an idea about how things work. So can you just see the screen?
Yes, sir.
Yes, sir.
Sir.
Sound is audible?
Is influencing our lifestyle from the
sound is audible? You are able to hear?
Yeah, sir.
No, video sound is audible for you?
Yes, sir.
way we react to the way we behave.
No, I want to ask you whether the sound of the video is clear for you.
Yes, sir. The video sound is clear.
Oh, very good. Thank you. Then
From
continue.
air conditioners that you can control with your smartphone to smart cars providing the shortest route, or your smartwatch which is tracking your daily activities. IoT is a giant network with connected devices. These devices gather and share data about how they're used and the environment in which they're operated. It's all done using sensors. Sensors are embedded in every physical device. It can be your mobile phone, electrical appliances, vehicles, barcode sensors, traffic lights, and almost everything that you come across in day-to-day life. These sensors continuously emit data about the working state of the devices. But the important question is, how do they share this huge amount of data and how do we put this data to our benefit? IoT provides a common platform for all these devices to dump their data and a common language for all the devices to communicate with each other. Data is emitted from various sensors and sent to IoT platforms securely. IoT platform integrates the collected data from various sources. Further analytics is performed on the data and valuable information is extracted as per requirement. Finally, the result is shared with other devices for better user experience, automation, and improving efficiency. Let us look at a scenario where IoT is doing wonders. In an AC manufacturing industry, both the manufacturing machine and the belt have sensors attached. They continuously send data regarding the machine health and the production specifics to the manufacturer to identify issues beforehand. A barcode is attached to each product before leaving the belt. It contains the product code, manufacturer details, special instructions, etc. The manufacturer uses this data to identify where the product was distributed and track the retailer's inventory. Hence, the manufacturer can make the product running out of stock available. Next, these products are packed and parceled to different retailers. Each retailer has a barcode reader to track the products coming from different manufacturers, manage inventory, check special instructions, and many more. The compressor of air conditioner has an embedded sensor that emits data regarding its health and temperature. This data is analyzed continuously, allowing the customer care to contact you for the repair work in time. This is just one of the million scenarios. We have smart appliances, smart cars, smart homes, smart cities, where IoT is redefining our lifestyle and transforming the way we interact with technologies. The future of IoT industry is huge. Business Insider Intelligence estimates that 24 billion IoT devices will be installed by 2020, and IDC predicts that IoT revenue will reach around 357 billion in 2019, resulting in a lot of job opportunities in the IT industry. Want to become a part of the IoT revolution? Come and master IoT with Edureka.
Okay, fine. You have seen a small video where you can understand that the importance of IoT and how IoT is going to impact the upcoming future generations. So this is what we have seen till now, and we are almost at the fag end of the module 3, and we'll be completing by Monday. So we'll then move on to the next message, next things further. Today we will, with this, we will wind up for today, and we will continue further in the upcoming classes. Is there any doubts or any discussions you need to have?
No, sir.
No, sir.
Okay. So, fine.
Thank you, sir.
Yeah. Thank you. And I'll be taking your attendance further.